Welcome back, Physical Science 20. So this is the last section in FC2, FC2.5 Concentration. So we'll be looking at molar conversions involving concentration of a solution to mole and vice versa using the correct number of sig figs. So concentration, the term concentration is used to describe a quantity of solute per unit volume of a solution. So quite often in everyday sense, we may look at iced tea, for example. So it would be concentration would be grams of powder dissolved in a volume of water. So in that case, it could be grams per liter. Okay, so solute, solvent, solution. So the solute is what gets dissolved. So usually in cases we think of solids, right? But we could have gases dissolved quite easily. We could have liquids dissolved in liquids. And solvent is the substance that does the dissolving. So most often water is going to be the solvent. And of course, together they make up the solution. So then from there, we look at concentrated versus dilute. So if I'm talking about a concentrated solution, I'm talking about one that has a large quantity of solute dissolved in a certain amount of liquid. Conversely, a dilute solution contains a relatively low amount of solute per volume. So kind of a qualitative way of describing it. Not giving numbers, just simply saying, okay, one has a lot, one has little. How much is a lot, how much is little? Well, that remains to be seen. So for example, sulfuric acid purchased by schools is far too concentrated to be used in most investigations. Some of the acid is diluted by adding a small quantity of acid to the water. It is then ready to use for investigations. So yes, performing a dilution is very important, so we don't have to use concentrated acids. Chemists find the most recent or convenient to express solution concentration in terms of moles, which is an amount per liter solution. So solution, not solvent, the whole thing. Traditionally, this is called molar concentration or molarity of a solution and used the symbol big M, but kind of we refer to it now as this big C for molar concentration. It's determined by dividing the amount in moles, so of solute. So the solute amount in moles divided by the solution amount in liters. Okay. So if we look at the next page, we can see that. So molar concentration, amount in solute over solution. So we have C equals M over V as a little relationship we can use where N represents, you can think of the M as being number of moles of solute, and of course volume in liters. And of course the big C is concentration. And as you can see, we're going to have moles over liters. Moles per liter, or as I mentioned on the first page, big M for molar. Okay, and with that formula, of course, what we could do here is have different pieces of information. Sometimes we have the mass, and we have to figure out how many moles or vice versa. So N is measured in moles. Mass is measured in grams, so we could go in this route here, which of course you need the molar mass to go from moles to mass or mass to moles. And sometimes we're given the volume in milliliters, so we'll have to convert it into liters, or sometimes being asked for vice versa. So that's a key thing to note with this. So the most common concentration unit is moles per liter. or molar. And here's some examples of real life stuff. So hydrochloric acid, it comes in 12 moles per liter, or 12 molar. Nitric acid, 16, and sulfuric, 18. So a stock solution is one that you usually get shipped. So it's a concentrated solution, so quite often you need to dilute that a little bit. So let's look at an example. Example, calculating molar concentration. Sulfuric acid is a solution of hydrogen sulfate in water. When concentrated, it's extremely corrosive. If I have 25 mils of it, and it contains 44 grams of hydrogen sulfate, what is the molar concentration? So what is the molar concentration? So I'm given, let's see, what am I given here? I'm given, so volume, I was told I have 25 mils, but of course we know we're going to have that in liters. So move the decimal 3 places to the left, and I get 0.025 liters. And the amount of moles. Now, I'm told that I'm dissolving 44 grams of hydrogen sulfate, so I kind of know it, but not quite. I know the 44 grams, but of course I can easily figure out how many moles that is by dividing by the molar mass. So yes, I'm going to have to figure out the molar mass of hydrogen sulfate, H2SO4. So molar mass of H2SO4. So for every 1 mole, I have 2 moles of hydrogen, 1 mole of sulfur, and 4 moles of oxygen. Okay, so and then 1 times 32.07. Oops, I should have put oxygen here first, and then we see how much it is. So 32.07 plus 64. So that's going to give me a molar mass of 98.08 grams per every mole. So that's what I'm going to get used over here. 98.09. That's what you need for going from grams to moles. So cancel, cancel. That's going to give me 0.448567 moles. Don't round off just yet. Leave it like that because we round off the final answer. So we know what, so C equals N over V. We now know what N is. We know what V is. So we could just simply substitute that all into here. All over. And now, yes, volume has to be in liters. So of course that's going to give us 17.9427 moles per liter. And if I look at my original question here, so 44, 25.0, so I'll go with 44, 2 sig figs. So that's going to give me 18 moles per liter, or 18 molar. So that's what we get. So that's a case of given N, given V, figure out C. We'll look at 2 more examples, kind of rearranging this and looking at the other ones. So on the next page, we'll see a different one here. So household chlorine bleach is 0.067 moles per liter. So of course that's big C, right? Sodium hypochlorite, as seen on the right over here. What mass would we need to make 225 mils? So we know big C, the concentration 0.067 moles per liter, we know that. V we kind of know, 225 mils, which of course is 0.225 liters. So move the decimal 3 places to the left. And N is what we don't know. So we're going to have to figure out, so we know C, we know V, we'll have to figure out N. Then of course it's actually asking for mass. So then once we know N, we'll be able to figure out mass. And of course to go from moles to mass or vice versa, you know darn well we're going to have to figure out the molar mass of sodium hypochlorite, chlorite. So for every 1 mole of this, I have 1 mole of Na, 1 mole of Cl, 1 mole of oxygen. So 29.9, 1 multiplied by 35.45, and then 1 times 16. So the molar mass here works out to be 74.44 grams per mole. So when I get to this last step, I know what I'll have to do. I'll have to multiply by that to get the number of G's. So C equals N over V. So C, 0.067 equals N over 0.225. So I know I'm going to have to multiply each side by 0.225. So 0.225 multiplied by 0.067. So that is going to give me, let's see, that's going to give me 0.015075 moles. Okay, so I now know what the number of moles are. And of course, so from there, 0.015075 moles, and then use the molar mass. 1 mole represents 74.44 grams. All right, so if we do that, multiply that all out, we get 1.122183 G's. But if I look at my numbers here, 2 sig figs, 3 sig figs, so we'll go with 2 sig figs here. Keep the 1, keep the 1, the next thing is a 2, so 1.1 grams of sodium hypochlorite. All right, we'll leave it there. So we did one in which we need to find out N. The last example we'll do when we come back will be finding V. All right, we'll see you again.